But yeah, Jan, do you want to go over your findings first, or do you want me to show you the little demo? It might be better to go over your findings first because we can talk with it with Dimitri. But
Yeah, sure. So I sent an update to the issue.
mhm,
I was playing with the Kuzu locally, and I put a couple of findings there. The most important thing is that by default, Kuzu is not built in the way that it would expect that you open many different database connections. It rather aims for basically single connection which you work with.
mhm,
After some experiments or digging, I was able to basically tweak these its memory settings, and it has C bindings in Go, so it's
yep,
easy to write a simple Go test script
mhm,
on top of this, and it's possible to run thousands of open database connections with this. It's pretty fast, but on very simple database. I don't have a real life database. Maybe Angelo, you might send me your database of GitLab
yeah,
if you have it, so I can test it on it. But with these memory tweaks, I can imagine that this might still work and it might be a viable solution
mhm,
because the time penalty for opening the database, at least the simple one I used, which is just 100,000 of nodes but nothing else. I think it was quite fast. Yeah. It locally it has 30 milliseconds to open
that's
the database connection and run a query to search a node by the name on in this database.
wow, really?
So, but let's see what we get with real database.
Yeah,
I think it will mainly depend how big the database will be
mhm,
because what it does is that Kuzu, when you open the database connection, it allocates some memory buffer, and it basically reserves this memory, so it's not possible that you would open millions of connections for free.
yeah.
Uh, and
I mean, like if we were to do a connection per database or like repository per
yeah,
database.
exactly. Uh, Basically, having a connection per project, which is also a separate database. So, so it's not realistic that we would keep open connection to all databases, but I can imagine that we would still keep open connection to all the actively used databases at the current time on the
Yeah,
server. Yeah.
yeah.
And if we can do this, I still think that this might be a viable solution because what attracts me still is the isolation of all the repositories from each other, which provides better security and the simplicity of this solution. Yeah, we can.
Yeah.
It's much easier to scale this horizontally than having one big monolithic database,
Yeah.
which we attempt to scale through some cluster nodes of the solution provided by the database. So that's it. I
You-
think I would be curious. What are others' thoughts on this? I pinged you on this issue, so please ping me there.
Yeah. Do you think,
And
do you think, so you're thinking we would still segment it by project or like each data, there would be a database file per project is what you're thinking? Or, um,
yeah, I think it's the most reasonable solution to go with. I Uh, I asked there Jordan what would be a product requirements regarding cross project searching,
yeah,
which I think is still possible with this approach, but not in the way that you would be able to search across hundreds of thousands or thousands of projects at once. But I think that in case of knowledge graph or project graph, the needs are slightly different than if you are than what global search team has with
yeah,
searching. Because for global search, it's much more common that you want to search your
across,
namespaces.
yeah,
Yeah.
versus you have an isolated
But
query. Yeah,
if you work with your knowledge graph for a project, I think it's more common that you work with the project itself, yeah. That
yeah.
there are much less use cases when you would need to search for your namespace for the graph DB query.
Well,
But
at most, you'd probably want to try to connect one isolated query. Like, hey, I'm calling this function. I'm using a library in this function, or sorry, a function in this library, and I want to check another project that uses this library and where that function is being called and get the graph nodes from there. Those are probably the use cases for like cross repository knowledge graphs, is my guess.
so if you are searching for some usage of this way, I would expect that you would rather use either the semantic search or the global search services for use cases like this, like yeah, where is some library used or something like that.
Yeah.
Well, for a knowledge graph, it's yeah, you could still search for where is called some function called blah blah
Yeah.
blah. So yeah, there would be this weakness of this solution.
Yeah,
Do you
And
maybe
think
it's
if you did, what were you saying? Sorry, Dimitri.
just want to mention maybe that this is not the appropriate, how to even call it. Graph database is not supposed to be used like that. We can use advanced search, we can use exact code search to find maybe the function usages, and we can use
yeah,
graph databases for graphs.
For yeah, yeah, for getting the actual, and maybe a combination of the two would be the best. If
It
you
might,
want to do a namespace search, you search what you're looking for, and then you take that and construct a graph database query and just query on the individual projects, essentially.
yeah. And I also wanted to mention maybe it would make sense to benchmark Rust-based Kuzu just
Yes.
to compare the performance, because I think only the indexer should be written in Go because we're going to call
Yes.
Gitly. But that's not necessarily the case for the web server.
Yeah. Yeah. The client, the proposal is going to be that we write majority of the business logic in Rust, and then the Go binary will supply the primitives for resolving files, you know, resolving directories, etc., and whatnot. So my guess is the client binding will be in the Rust binary for Kuzu, the connection opening, uh, and
uh,
implementation.
so uh, so yeah, we can do benchmarking in Rust in case it's some magically better, but I think it's not because for what is potential the major bottleneck is the memory usage. Yeah. I mean, what we could compare is how long it takes to open database connection in Rust versus Go wrappers on top of Kuzu. Yeah. Well, this is what you mean.
If anything, it would be the same though, because it's just the same. It's just bindings, right? So it's still
Yeah.
running the underlying C and C++ code.
Yeah.
Um,
So
it'll probably be the
I would expect not big difference. But also I wouldn't strictly require that this service, if we go this Kuzu way, that this service needs to be written in Rust or something else, because it will be independent on the indexer itself, I assume. Yeah. You just need to feed or pass from indexer the processed data in some way. It can be CSV or whatever. Yeah. You
Yeah.
can just pass it and this service will process it in some way.
Yeah, we could do that too. The on the client, we definitely want to keep it Rust based. When I talked to John Slaughter and a lot of the editor extensions engineers, we need to ensure that it can run on any machine, basically. That's one of the requirements. And Dasha was even telling us there's people using like 2010 Dells. So like we cannot afford anything anything that is big on memory. So
To clarify my point, I think that in production on server side, the indexer node will run separately from this knowledge graph node. Yeah, because this knowledge graph node or multiple nodes will be focused mainly on managing connections to the database itself,
yes.
or basically this one. Yeah, so I don't expect we would put more load on these nodes with also indexing and stuff like this.
Yeah. Okay, that's good. Do you think for scaling this, I mean, we're gonna need to test it. My plan this week, I was about to do an async update. So we got the one parser thing. We're doing that. Um, I'm meeting with the VP of Secure today to just go over anything any suggestions they have. But my plan is to get a project created for the one parser. So we unblock embeddings, and then we can just start building it. And I think that the initial bindings are going to be probably Node, Nappy. I'm going to argue maybe we don't worry about WASM right at first, because we want to make it work for the desktop usually. But I'm gonna try to see how difficult it is gonna be to do it in WASM. There's a really good project out there called AST grep. So I'm gonna put that in the research that I did. You might have heard of AST grep already, but it's not a really good project, but it's cool. It's doing it's very similar to what we're doing. So I'm actually gonna follow how they're doing WASM, I think. Um, um, and then along with the other project, the GLQL project. So those bindings, and then of course a Rust crate, so we can export it to the knowledge graph indexer. So once I have that, at least the initial template in tandem, I'm gonna start working on the Ruby and Go and JavaScript. Just try to get a basic business logic so we can create some nodes. And then I'll get that to you, Jan, and then we can run a real test on the monolith and all the GitLab projects maybe. And do some serious testing on the back end. What do you think of that?
Yeah, sounds good to me. For testing, basically real life database, all I would need is some whatever project you already have indexed would be fine for me. If you have GitLab, that would be
Yep.
super awesome. And I don't need any other. Yeah, I just want to test how
Large.
long it takes to open the connection to bigger
Yeah.
database and how big buffer pool, memory
We
buffer
need.
pool we will need for such
Yeah.
database, because I suspect this will be the biggest issue.
Yeah.
Because what is concerning, and I wanted to ask you,
Yeah.
I noticed that if I open Kuzu connection and
Mm-hmm.
I keep reusing the connection by multiple queries,
Yeah.
the memory usage increases until it fails. Okay, I don't have more memory page
Memory.
I could allocate in the buffer pool.
Yeah.
So it might be that you didn't hit it because by default, Kuzu allocates 80% of your available memory, but you should see increasing usage of
Memory.
the Kuzu process locally.
That's interesting
So
because even when I was writing to the database, is this just for querying that you noticed, or also writes?
both for writes or creating the database, well, actually, I don't know. For writes, I just noticed that you need bigger buffer pool, but I'm not sure how much memory increase is there. I'm not sure.
Yeah, I didn't run into that. So the first, and I was actually doing it wrong at first. So I was trying to write via queries for all the data, and I was like, it was super slow, and I was like, I'm doing this wrong. And then I saw they have the import. So whenever you're doing more than like 100 nodes of writing or whatever, you want to just do import. Because they
Yeah,
query. Yeah.
I do import of all nodes from CSV for
Yeah.
testing purposes, of course.
Yeah.
But this is related to another question. I noticed that they support indexing only by some full text search on nodes or vector search. Is that correct? And this is supported only by some extension.
What's the question
So
again? Sorry.
it seems that the indexing is supported only through some extension, uh, TFS extension, which you need to explicitly enable. And I was surprised that only full text search and vector search indexes are supported. There is no some, I don't know, B3 index or something like that. Is that
Um,
correct?
Not that I saw. The way I did it was I don't think I had to enable anything. I just wrote CSVs and I defined the relationships when importing. I didn't have to enable anything specific. Let me double check. Um,
I mean for searching there, then not for importing.
oh, for searching, yeah, I didn't have to set anything based on what I found.
I would expect it's slow then, isn't it?
Well, I was only using the Explorer,
Mm,
and I'm assuming the
okay.
Explorer runs the exact same query the client should, right? Let me see.
Never mind. We can check later to not slow to
Yeah.
not block Dmitry and Vitaly on
Okay.
call.
A, a quick off topic. So in the Kuzo documentation, I see differences in the Rust and Go examples. So in the Go example, I see buffer pool size, but in the Rust example, I don't really see that.
Mhm.
Is it just take some default value, or maybe it's implemented differently for Go? Maybe we should still double check the Rust implementation. Maybe it's more memory efficient.
Yeah, we can take a look.
I can check where I created. Let me find Kuzu.
And I think Go garbage collection can also play a role in this.
Yeah.
And that's not the case for Rust.
Moving KuzuDB directory if it exists.
But given the Kuzu is written in C++, I would expect that from Rust you still call some bindings
Exactly, yeah.
of
Yeah.
this underlying code. And the whole logic of allocating memory buffer pool happens
Binding.
in this C++ logic independently on what you call from Rust. Yeah. In Rust, you just call these C API methods or functions. So
Yeah, that's true. I've just noticed this difference, and I just got curious. Why is that? Why do you need to specify buffer pool size for Go, but not for Rust? Maybe the bindings are different.
It could be, yeah. I mean, Rust, it statically links in Rust, so I think it actually compiles the C code and embeds it in the Rust binary. I don't know. And they might be, C might be compiling it with, or sorry, Go might be compiling it with CGO. So the code, the underlying code might look different. I don't know. We can also inspect that. Like I can do that pretty quickly, just compile both and then just look at the underlying compilation. See what the difference is. I don't have anything that I need to specify like a buffer pool. It just has the connection and then I can just read and write to the connection.
yeah,
So
if you don't specify it, it just uses default value
default.
for it. So
Okay.
it's not a requirement to set it.
Okay. So the one question I had is, so for scaling, is it theoretical because we put it on an API service, is it possible that we could put like for handling multiple queries, some type of load balancer where maybe you'd have like one pod dedicated to a larger repository, and then you can just route the traffic and then combine them back, depending on the query. If you wanted to do like essentially like a pod per project. I don't know if it would be great. That'd probably be like involve some advanced scheduling and all that stuff, but and it's probably something we wouldn't really need to handle at first, but I'm wondering if that's like if you're thinking that one pod would handle multiple connections to each different project file, or if you're thinking like just horizontally scale and handle different connections that way. I was just wondering what you're thinking with that.
So my expectation was that one node, either if it's pod or one VM or one process, would handle uh, mm, many different connections to to different databases. Yeah.
Mhm.
So I would expect that we will have that each node. For simplicity, let's assume we use one big machine
Mhm.
and it runs this service, and this service will keep multiple pools of connections to the embedded Kuzu databases.
Yeah.
And these pools will have different buffer pool settings depending
Based
on
upon
the
some-
size of the
That
repository.
makes sense.
So we know in advance how big each Kuzu database is. So we can decide that for GitLab-sized projects,
Yeah.
we use pool of connections, which uses a memory buffer of, for example, 1 GB, yeah? And we
Yeah.
allocate much bigger portion of this machine for it.
Yeah.
And for all small connections, we use a pool of connections with much smaller buffer pools.
That makes sense. Yeah.
The benefit is that for Kuzu connections, as long as you have read-only connections, you can open
As many as you.
multiple of them. Yeah, as
Okay.
many.
That would be huge. And then I'm assuming we would create a copy of the database with the new indexed database and swap out
Exactly.
files. Would
Yeah.
that corrupt anything if you're like in the middle of a read and you swap anything out?
So this is file-based database. So as long as you have open file descriptor to a file, the file system keeps the link to the file, and once you close it,
I
basically
see.
it unlinks the data. Yeah,
Yeah.
but these are details we can investigate later.
Yeah,
It might be that.
implementation. Yeah.
Yeah, yeah. I don't think it's necessarily a blocker. I mean, having not having access read write and multiple read writes into one database, that it's not a blocker.
Okay.
What I wanted to ask, Dmitry, is you mentioned originally that we could reuse the Zookt service to run this. I couldn't find this Zookt service. You mentioned we have a fork for this for GitLab purposes, and it wasn't clear to me how this would work behind this Zookt service, because my understanding was that Zookt service is for Zookt ser purposes. So mixing it together with some Kuzu service seemed a bit weird to me. So I wanted to clarify this or find more details about this approach.
So Zookt indexer is not a fork. It uses Zookt library to index our repository. So it connects to Gitly, indexes stuff, and also another process.
I
Oh,
meant
sorry.
Zookt. I thought there is also Zookt web service or service to which you connect when you want to do searching, not indexing.
Yeah,
I'm not concerned
right now
now.
it's a single binary, and on .com it's a stateful set. So right now it's 64 nodes. I was just thinking, if we want to quickly launch it, we could potentially deploy it as a sidecar or something else with Zookt, or even potentially include it in the binary as a different submode, because indexer and web server modes for Zookt are just different modes of operation for this binary. I was just thinking how we can shorten the time to market. But we can totally create a completely separate project. Maybe you can replicate a lot of the approaches we took with Zook, because it's very similar. It's also M-mapped files on disk. It's horizontally scalable. It's also project based. So there are a lot of interceptions between these two different projects.
Yeah, thanks for clarification. So if you could send me a link to this Zookt binary or the repository for this Zookt we use
I'll do it now.
it would be cool. Yeah, sorry,
Just
that was all from me. So depending on your questions, we can dig deeper, or we can move on to Angelo demo.
Yeah, no, sounds good. Vitaly, did you have anything?
No, I haven't really looked into this besides Rust, but yeah. And I will be away for next 2 weeks, so I'll probably need to trust you and think after this.
Okay.
To provide more context, or just to sync up with you, Vitaly is working on was working last few days on adding Ruby parser into the POC, so we could test the POC with the monolith, which management was asking about too. In case we would proceed with this Kuzu approach, it might be waste of time to some extent. That
Not really. That's the one thing I wanted to actually pick both of your brains, or actually all three, because I'm not a good Rubyist. I'm not sure if I like Ruby, but but no, I like it so far, but it's probably just a skill issue. But what I'm trying to think through, is how we want to link references and definitions. Because Ruby, everything's an object, right? And maybe there's like a general way, at least for the monolith, we can figure out how to link those two things. So like I'm in one file, I'm using XYZ class. How would we traverse the tree to go through that class, get the function calls, for instance, then link those calls to the appropriate Ruby classes throughout the code base? Does this mean we have to load the entire thing into memory, like all the different function calls in memory, so we can do the lookup, or maybe we can write it to a temporary SQL database when we're doing the indexing? I don't know. So that was one thing I wanted to.
I have answered to this. We don't do it now in POC, but I was experimenting on a separate project and parsing this. With the way I did this, I was differentiate two different like functions and methods. A method is basically a function inside the class. It's of course there are differences for different languages, and we need to have separate parser per every language.
Yeah.
For example, Ruby, Python, they are similar in the tree-sitter. There are some things called differently. For example, in Python called function definition, in Ruby it called method, and stuff like that. In Go, for example, there are no such thing, but
yeah, we would have different tree-sitter queries for each.
What I did, I get if it's standalone function, I just took a file and the function name.
As
if
an
it's
ID.
Yeah, so these two things and store them into a graph database. So and we have file as a node in the graph database, and we have this function as a node, and we have relation like file contains this function.
Yeah.
And the same with class. File contains class, and class contains method.
Yeah.
And I was also checking the calls. So inside some function method, there is a call, and we can sort of figure out who is calling and also build the relation.
That's what I'm wondering. How do we link the call to a cross file?
Yes, sometimes it's possible to see because you will see, I think, identifier, and it calls the method, and you can sort of find who calls it from this function, from which function. It's visible on the graph. I'm not sure if I have a demo right now, but once you have this graph, you know from this function, this function is called. There probably could be some complicated things when you have a bunch of functions with the same name. I don't know if we can identify this 100% correctly.
Yeah, I mean, not even the Ruby LSP does it correctly, or at least the Solar Graph one that I use. Like when you try to go to references, it gives you like 10 or something if it's like depending on how high you are.
There might be issues, but we can start with some solution and see what we can optimize.
Mhm.
But in some cases, it will work.
Okay.
And yeah, and once we have this relation, if we search for this function, we can get like a file it relates to, and the color of this function or callee, and also get a file and just get these two files and load them and stuff like that.
I see. So you would, so the query itself would look for the function call, and we would search that way rather than trying to link them up front, is what you're saying?
Well, so but when we parse this using tree-sitter,
Yeah.
we will also store them in the graph database, and this is graph. And
Yeah.
and then when we query them, we can say, give me this function and what it's related to, like where it called from and stuff like that, where is the definition of this function.
Yeah, that
So
makes
yeah, there are two passes or two rounds of parsing the source code. Yeah. First, you create all the nodes, and on second go, you create a relationship between calls. I
yeah.
pasted to chat a link. And what we do is that I think we discussed it on some previous call that we currently don't identify from which exactly class is some method you might be calling. So there is a simplification that if the tree-sitter notices that you call some other method,
Mhm.
it just links it with any other functions with this call definition, with this function definition in the project. Yeah. So if there is a calling print function, I link this function that it calls
I see, and
all the print function definitions. Yeah.
that's where the match is what you're doing here.
Yeah, it uses the match, yeah. So the match will return all the matches of all the print function definition, basically, or
Okay.
so.
We need to figure out how to do that with the import with Kuzu. So that's what I was trying to think through. But
So did
Which
you
is
test how fast is it to just use the same in Kuzu because it supports Cypher too, yeah. So we could just create the nodes in Kuzu and then use similar query there too, right?
we could do that. I have to double check how it's importing the data. I think it's probably very possible that we can just run the same matching during import.
But I suspect it will be much slower than doing just imports. Yeah.
Yeah,
If you would do everything in memory and then
yeah,
just do the import of it, it will be for sure faster.
yeah.
But yeah, the downside is that in memory you need to handle all these matching logic, yeah, matching everything together.
Yeah, yeah. Okay, that's good. Yeah, this is good. And Vitaly, if you can link me whenever you whatever you have before you go, for the Ruby stuff, I can try to integrate it into the current indexer I have that uses Kuzu.
yeah, I'm trying it right now and integrate into POC, but I also have like a separate project where I was experimenting with Ruby, Python, and Go, and quickly find this.
Okay, that's great. And then I wanted to show you guys calling Rust from
And
Go.
yeah, one more point I quickly want to touch about these imports. With Ruby, it would be a little bit more complicated because in different languages you import on top of a file and then use stuff.
Yeah,
In Ruby, especially in Rails, we have this auto load thing, which has nothing there. It's just
that's what I'm. That's the main thing I was
prerequisites.
trying to figure out is like I don't know how you what's the convention? Is it file based? Like you check the file path and see if it matches the class that's being used or something? I don't know.
Yeah, in this my experiment project, I didn't use imports at all. I was just going through file and was looking classes in the file and then methods in the class
Yeah.
and then stuff like this.
But if you
Yeah,
have
but
like if you have different modules, right, that you define, do those modules always match the path in Ruby or no?
you can have several classes and modules in a file, and it's not like you have to have separate module in separate file.
And yeah, and the namespace or the module name doesn't reflect the full path. Yeah, so you cannot deduce the file path from the namespace.
Quick question. We don't want to plan, sorry, we don't plan to index feature branches, because I think if we do, that's a huge problem by itself.
So I think this was mentioned by product management before, and there are some use cases like, for example, you want to review some merge request, which obviously uses a different source branch, for which you would actually need this different source branch. And I remember that you raised big concerns regarding this for embeddings. And you mentioned that you want to discuss this further with product management. So for knowledge graph, if we would go with this Kuzu approach, I can imagine that it could scale even per different branch, because if one file, if, for example, for small repository, this database is 20 kilobytes big, you can easily create many different databases.
Per branch, yeah.
This would scale probably. So I can imagine we would support it.
Yeah, what we can also try is to index only difference. For example, if I see difference in between main branch and feature branch, we can check the files changed and index only those files. And then, when we do something, replace these indexes. So we don't need to index. So if it's like 10 branches, we don't need to have like 10 copies. So we can have main branch and 10 indexes of different, does make sense, of files only changed in these branches.
Well, you could store the branch probably as part of any of the node and just query by branch, just ensure it's filtered by branch, right?
So we've just had a parent session with Maddie and Arturo on that exact topic, how to support feature branches for the sub team. And storing the branch names is kind of the flat approach. Zook uses this approach, but I think if we want to properly support branches, we need to rebuild Git. But I think it might be too complicated to add another graph on top of the graph we already have. Because you can create your branch from any point in time of any branch. So,
well, you would want to only store the current state, right? We don't want to be able to query by commit, right? Or do we want to
not but by commit, but I think if you have a feature branch that was created from master maybe a week ago, you need to store what was in the master branch 1 week ago.
You're right. So you would have to do a
but
copy.
It has the commit hash, and we can compare the difference between hashes, no?
We can, but you would still need the version, the knowledge graph of the version from when you create it, when you check out your branch.
Makes sense, yeah.
Yeah, like if you
Or
delete a whole directory or something, right?
Makes a little bit more complicated. Yeah.
or you could rebuild the diff whenever you update the master branch and you update the knowledge graph for master branch, you would need to rebuild the diffs against your current master. Yeah. What I wanted to mention that for knowledge graph, if we store each of them separately in a separate file, and the file is small enough, we wouldn't have to bother with anything of this. We
Yeah,
would just always store the wall knowledge graph, and that would be simplest. Yeah.
that
Yeah,
makes
it
sense.
depends how fast will an index. Yeah.
I think it, yeah, I think, and on the client side, we also need to look at that. I was thinking on the client side, we just a user changes branches on Git, and then we just reindex the whole thing, just wipe it or reindex. Because you only want what's currently there, right? For the most part. I don't know. We could get more complex later on, but for a V0, like current state seems like the best. Okay, yeah, that's good. We should make that as part of like create an issue for that, like how to handle states. But I wanted to show you guys the Go from Rust real quick. Because I thought it's very interesting actually. We wouldn't probably do this. We probably have the Go binary indexer that we're going to use talk to the knowledge graph Rust library. So it'll use similar techniques, but this is mainly for like the embeddings. So let me show you, or like the one parser, if you will. Or if we want to bifurcate the knowledge graph indexer, like the server side is Go based and the client side is Rust based. You would use this directly, but so I have this repo here. I just called it GitLab code parser FFI. Can you see my screen?
Yep.
Okay.
Could do a little bit bigger, I think.
Better. Okay, so the README kind of explains what it does, but I'll just give you guys a walkthrough because I figured it'd be easier. So how it works is Rust. I'll just start from the Rust side. Rust exposes in a standard library FFI, and particularly it exposes like different C primitives, right? So I can go in here and I can oh, my Rust analyzer isn't working because I'm at the top level of the repo, but I can go in there and just ask for the different primitives for C, and then I can create my structs from that. So just as an example, like we can just see where C string here is used. Let me find, all right, so we have the C symbol array as an example. Because we're going to need to return more complex information than just a string back and forth, and we don't want to actually serialize anything because that's just going to kill the performance. So what I have here is just like this symbol structure of like the data that we want to give back. So the input for this program is going to mimic exactly what we're going to try to go for with the library. But it's just like extract symbols. So we have the actual code just as a regular string, and then the language ID. And then you get back symbol info as an example. And so this is the internal function. This is what the Rust crate will expose. So if you're a Rust client consumer, you'll just use this. But we'll also create a C crate or like a C bindings crate or a Go bindings crate, whatever we want to call it. And this actually binds the C data structure to like the actual function call. So you can see we're taking in a C string, C integer, and then returning that thing I showed you. So which is just like, in this case, it just extracts symbols from the code. And so yeah, so you just, it goes through the logic that we were doing with tree sitter. So we actually traverse the tree. I created tree sitter queries for like a bunch of different languages for extracting stuff. It's simple. It's nothing like comprehensive. So for Ruby, I'm just, getting some of the method calls essentially. Python getting import statements and these are import queries. And then there's also like function queries that I have here. So method, function definition, etc. And then getting classes as well. So then, so we go through, the logic is just basically running the queries, capturing the nodes, regular tree sitter stuff. And then we're returning the symbol info. And then we're taking the symbol info and actually allocating it as a C symbol array. And so then we return it at the end here. And so what happens is there's this really cool utility called cbindgen. So we just define the different structs that we're trying to generate C bindings for. And this tool will actually generate the C headers. So we have all of the various C headers. So this is like the essentially the contract between Rust and C and in particular Go. And so then Go is beautiful because Go has CGO, right? The CGO compiler. And so what I'm doing here is I'm embed. So there's two ways you can embed it. So this is one thing I'd like to get your opinion on. There's two ways we can embed it. There's dynamic embedding. So the library is, I think, compiled when you run it. The other way is statically embedding it. So it compiles it and then actually embeds it. So I just chose the static version. And so we're just looking at the headers here. We're including, standard C library and then a build flags here for making it static. And this is the, if you go to the target and the actual build from Rust, if you go to release, I have the actual lib hello that, it's going to be calling via FFI. And then, yeah, so then you can actually just use it. So this is doing all the same things, so all the different languages here. And what it's doing is running analyze file on all of the fixtures. So I created a bunch of fixtures under this library. So, TypeScript, sample, Ruby sample, Go sample, etc. And then it's running the Rust code, C extract symbols, and then at the end of the routine here is just going to free up the allocated memory. But you can iterate over the extracted symbols, and because we have a defined struct for them, so the symbol kinds here, we can actually just use them essentially, and like we would as normal data. And so if I run it, this is not the right library. Go FFI. And I based this off of another guy's project. I just integrated it with Tree Sitter to ensure that this will work with Tree Sitter, because Tree Sitter has C code it uses. So we're like compiling C to Rust to C to Go in a way. It's kind of funny. But if I do make run, so this is going to build the Rust code, all the Tree Sitter dependencies, and output the Rust code, and then the Go compiler is going to actually compile it and then run it. So then I had some performance stuff here too. So TypeScript, we're like, here's the TypeScript file just to show you. So we have a bunch of imports, we have interfaces, a class, etc. And so you can see we're kind of extracting all those things, and then it's up to how good our logic is, right? For what we want to extract. And then this is the performance from Go. So this is measuring when we call via FFI all the way through. And then also we can measure the performance on the Rust side too. But this is just kind of seeing what the performance and overhead is. And this is like, some of this is really good, like having it I've never seen tree sitter be this low. Usually on the JavaScript side, it's like no lower than 20 seconds for 20 milliseconds for just the query and stuff, and then you have the traversal. This is the query traversal. This is the parsing, query, and traversal all in one. And also calling from Go. So this is the Java example. This is Go example. So if I open up Go, just like a sample program. Yeah, so that's basically it. So the workflow would be basically we write the code, and then I guess on the more on the embedding side would use this library directly, but they write their business logic, and then we generate the C headers, compile for the specific OS, and then embed it in the Go. The only question mark I have is like, how do we export this if like we want the Go logic to be like do we want a Go binary, like a Go library in the project itself, or do we want others to just maybe consume the headers files here and just do its logic, or whoever is importing the library is the question. That's kind of a question I have, but or do we want to expose like a actual Go library or module, I think it's called, and let people just consume that raw Go code itself. The only thing is I don't know how we pass it all the way through. Like if Go can, I don't know if you can publish a module and make sure all of this is published with it. That part is a question mark to me, but you guys might know better than me. But yeah, I don't know. What do you guys think? Any questions? Concern? Thoughts?
Regarding your question, I don't know. Maybe we will see how we will use it in the indexer first on server side, but
yeah,
it looks pretty cool overall.
I think it might be nicer to use a module, but again, I'm not sure if we can bundle this with the Go library. Maybe you can take a look at other examples, even the graph database itself, because it has Go bindings.
You're right. That's a good point. We could. Yeah, we should check that out. That's a good point. Yeah, I'll check that out. But yeah, so I just want to show you guys this to make sure we know for sure it's working with Tree Sitter, which is good. So the library itself will just export WASM, Go, and JavaScript stuff, and then of course a Rust crate. And then we'll need to figure out what we want it to look like. So Vitaly, if you have like thoughts on what the input output should be, if you guys have thoughts. I just did, it's like really basic, so it's nothing fancy right
Yeah, I
now.
was thinking maybe we can provide one interface. As Dmitry mentioned, this FFI is, I don't know if he's still going to use this or not. This FFI is slow, and so I was thinking if we will just feed a bunch of files and get a bunch of data back as a, input output. And
Yeah,
if you want to parse one file, you can just pass the list of one file. And our part, I finished the book yesterday, and
awesome.
yeah, so a little bit familiar. This part which exposes this C thingy you mentioned, and the function itself, which you expose, this called unsafe Rust. So
Yeah,
this advantage of Rust is all this memory stuff, which makes, I think, a little bit more overcomplicated than it should be, but I don't know a lot of details. But once you expose this to FFI and all these things, it needs to be marked as unsafe because different languages cannot how it was explained.
Guarantee, yeah, they can't guarantee
Yeah,
that.
like it's different types and how they behave in free memory. So this part is, yeah. And I was thinking if it's possible to have only like 1, 2 functions we expose to the FFI and the rest we do
I
it
agree.
like a normal Rust
Yeah.
and stuff like this. But I don't have a lot of knowledge about this part. I don't know if it's, I mean, if you expose one function, does it mean all the code it uses like also unsafe or only this function? You know what I mean?
Yeah, and that's a good point because we do have to free the memory. So it's just calling, so I'm exposing two functions, one's for getting the data back and then freeing the memory as soon as I don't know what that I don't know what that balloon was, but so we have this I have this free symbol array, so I'll show you in Rust. So it kind of just goes over that already allocated memory and frees it. So we just have to ensure that this happens, right? So we'd have to have some good fuzzing. But like you said, if we expose most like more of these, then we need to ensure that it can be cleaned up. I don't even, it might be even possible to ensure it's cleaned up in the same function call itself. I don't know. That's a question mark, but um, yeah,
I
that's a good
also
point.
don't know. One of the idea was to like return, I don't know, the JSON, but there is discussion with Dmitry again today. I was reading what if we use it on Ruby, it will be slow to deserialize this
Yeah,
JSON
yeah,
and stuff like that. And yeah, so I don't really know what's the best way to do this.
yeah, yeah. So I wanted
Yeah,
to get it working, but
we can experiment and try to expose less and let's see. Since it's internal API, probably we will we will be able to change it as
mhm,
yeah, to
yeah,
make it better for us.
but yeah, sounds good. So I was gonna hopefully get a project started soon, created soon, so we can start looking at this stuff, and then embeddings team will also need to start looking at it. Um,
By the way, the embeddings team subgroup might use a Go indexer. You might have seen
yeah,
my my
I saw
suggestion.
that. Um, yeah, and then Ruby. There's already an existing project out there, right? I think it's the one we use for Markdown, where we wrap a Ruby gem around.
Yeah, Markdown and
Rust.
Prometheus gem. That's
Uh,
another FFI to Rust.
so we can look at those, but I'm wondering if we need to start with if we need to support Ruby right now, if they're gonna do a Go indexer instead of Ruby.
I have another question, maybe someone know. Not quite familiar with gRPC. Would it be faster if we use a gRPC server on or vice versa on Rust and on Go and communicate between them? Or
hmm, could be like we would create two services or something,
yeah,
or
so one will be a server and client, and once we define this protocol, again, I only know in theory, but not much as well. I
hmm,
don't know how slow is it comparing to FFI and stuff, and maybe a different way of communication.
My gut is telling me that it's slower than FFI, but we can always benchmark it. I think gRPC is more for for different services to communicate. So
Okay.
maybe that's not exactly the best use case here.
Yeah, maybe. Just again, throwing out ideas.
yeah, we can try it. I mean, is it possible to run on the same pod? You'd have to you'd spin up Rust and Go, wait for both to be ready, and then have them talk back and forth, is what you're saying? right?
Yeah, I guess so.
Maybe quickly back to the Ruby discussion, it might still make sense to create a proof of concept gem to still test that everything's working.
Yeah.
We can use it from Ruby, not to be very surprised down the line when we want to use this parser in the monolith, even if we decide to go with Go for the indexer.
Yeah, you're right. I'll definitely do it. I think it should be okay because like if it worked for the main thing is tree sitter, right? Like making sure tree sitter works.
Yeah, exactly.
But I think it should be okay since Go has been working. But we should definitely double check, get a proof of concept. I'll try to
and
find
maybe some benchmarking, even simple benchmarking to test this FFI, how fast is FFI boundary crossing, if that makes sense.
between the languages you're saying, between Ruby and Go, or
Between the Rust library and Ruby, between Rust library and Go, maybe you can send, I don't know, 1,000 files or something and see how fast it returns.
okay. That's a good idea. Yeah, I'll definitely do that. Sounds good. But yeah, let me know if you guys have anything else. But appreciate you guys meeting last minute too. I think we're definitely making good progress, that's for sure. So all
So,
right.
cool. Thank you. Have a nice day. Bye.
Thank
Bye.
you.
Bye.
Bye.